Okay, simulated EGR cooler blockage test. After the fix to reduce NOx, many vehicles, VAG vehicles, are failing pretty soon. We believe because soot builds up in the EGR cooler or the EGR valve and causes the vehicle to fail. The idea of this test was to see if I could see if there was some way of predicting how vehicles, or showing how vehicles are performing, and get a bit of insight into what's happening. That was the EGR valve we just saw. Very quickly, the flow area through the cooler is 230 millimeters squared. The flow area through the pipework is 340 millimeters squared. I've got this restrictor plate, and the idea is to reduce the flow area to simulate partial blockage of the EGR cooler, and that's got a 10 millimeter hole in it, so it's 76 millimeters squared. So putting this restrictor in makes the ECU think that the cooler is 66% blocked. How it fits in: this is the cooler, this is the EGR valve, there's a 230 millimeters squared flow area through the cooler, it goes through this tube and to EGR, which pulls off a flow area of about 340 millimeters squared, and this 76 millimeters squared flow area restrictor can fit anywhere in this pipe. This is the baseline, this is the engine, this is the vehicle, should I say, my Passat 2.0 TDI. It was got about 28,000 miles on the clock at the minute, and it was fixed about 4,000, 5,000 miles ago. Results taken with torque, 0 to 3,000 RPM up there. This is the engine revs going up to 2,500 RPM and then back again. This side I've got mass air flow in grams per second, that's clean air into the filter, and I've got EGR commanded, that's the amount of EGR opening that the ECU is commanding the EGR to do. So mass air flow, as the revs go up, mass air flow goes up to about 30 and drops back down again. And the EGR opening, first of all, tells it to open up to about 55, 60% open. But then once the revs go above a certain level, it doesn't actually need the valves to be open quite so much to get the required EGR flow. And so it tells it at 2,500 revs to drop down to just over 30. As the revs drop down, it goes back up again, so on and so forth. So, right, try a number of those figures. I did a no-load test again, but this time with a vacuum solenoid unplugged, which raises a fault code, which actually shuts the EGR valve off. So there's no EGR opening. What you see here is that the revs build up, build down, and this time the mass air flow, clean air into the filter, goes up to about 50, back down again, all pretty well controlled. Next step is I put the plug back in, got rid of the fault codes, and put the restrictor plate back in. So now the ECU thinks that my cooler is 2/3 blocked. Immediately notice that there's a loss of control really on the EGR commanded. Right from the beginning, the ECU is commanding over 80% as opposed to 30%ish. And it remains pretty constant, that 80%, not what that blip is, until maximum revs, and then the ECU said, actually I don't need quite as much air now, you can shut down. But again, only shuts down to 60%. And then as the revs drop, it comes back up again, tells the EGR valve to open fully. And this is really because the ECU is trying to tell the EGR to pull as much air through the EGR valve as it can, and the valve is having to open almost fully to pull the required amount of EGR flow through. And in doing so, it's really lost all control. It's almost turned into an on-off system. You know, it either wants air or it doesn't want air. It's either on or off. So really, any finesse that there was in the system gradually adjusting the EGR valve opening to give you the required emissions performance has now been lost because of that restrictor. However, the total air through the vehicle and things is probably, you know, still the same or similar. Right, the next one, I had a look at my son's car, which is a 1.6 TDI, but that's got 67,000 kilometers on, and it's only a 1.6. And what you'll notice here is the similarity in the curves between my simulated blocked EGR and my son's real EGR, which I suspect, looking at these graphs, is also blocked, probably more than 60%, we don't know, but probably more than that. But strangely enough, in my son's car, there are no warning lights, there are no fault logs or anything. So just go through the figures again. Here's the revs increasing up to 2,500 revs and back down. This is the mass airflow, clean air into the vehicle, increasing and back down again. But this is the EGR that starts as soon as we start the car. It's demanded straight away 55%. As the revs increase, it says no, I need 80%. Please give me 80%, and it sticks at that level. It doesn't drop down. It's asking for 80% all the time, and then it just sort of switches back down to 60% until the revs sort of stop. So really, it's behaving very much like my car was behaving, and I would suggest that even though there's no fault lights on or logs, this EGR is pretty well blocked, or the cooler is pretty well blocked. Just to summarise, this is what the figures looked at 2,500 revs in the different cars. It says my car as fixed, fixed with the fault mode on so that the EGR is off. This is fixed with the restrictor plate, and this is my son's car unfixed. At 2,500 RPM, you can say that my car, when it's working normally in a fixed state, it's requiring 30 grams per second mass airflow and about 35% opening at 2,500 RPM. When the EGR valve is completely shut because of this fault mode, it needs more air into it. If I now get rid of the fault mode, put the plugs back in and so on and so forth, so the car's working in its normal fixed condition, it's back down to 30 again, but with the restrictor plate fitted, it's now have to go up to 65% opening as the EGR valve as opposed to 35% opening to get the required flow through it. So it's lost all finesse over the control. It's almost a bang bang on off system now that it's running on. The Seat's car, my son's car, the Seat, is pretty much similar to this. Obviously a smaller engine, so it's a smaller mass flow, but at full 2,500 RPM, it's saying no, I need the valve fully open, so lost all real control over the EGR. It's just basically an on-off system. What does that do for SUTs? Right, on my car, these lines here were SUT loading in the DPF against kilometres since last generation as the vehicle's driven, and these are different runs, you know, that I did over about 5 month period, I think 4 or 5 month period. It's all pretty similar. As soon as the fix was introduced, I noticed the slope of these lines changed. The SUT was collected in the vehicle a lot quicker, and instead of regenerating at 400 to 500 kilometres, I'm now regenerating at 100 to 200 kilometres, so 3 times the SUT going into the DPF. Right, this line here, the heavy line, is really one of the lines with the little experiment I was doing. So the car was fixed, and then I decided to enter the fault mode, which shuts the EGR valve, and almost immediately the SUT collected drops off and almost, or does match really, what I got before the fix. So unplugging the solenoid reduces the SUT collected in the car, which is what I've proved before. Continued in that position after the regeneration, which it did regenerate, and again it followed, you know, these lines. I plugged it back in again, so now it's in a fixed state, running as normal, and the line increased in slope, which is, you know, similar to what it was, you know, previously. So the car was back in its previous position again. I then put the restrictor plate in, and much to my surprise, the restrictor plate didn't reduce SUT. It kept on going up at this level. So my view is the restrictor plate with the hole in it on a car like mine, which has got a good EGR flow through it at the minute, doesn't actually reduce soot. The soot keeps on collecting at exactly the same rate, which is a bit strange because that's exactly what the restrictor plate was designed to do, was reduce soot, and it's not doing that. So where does that leave us? Preliminary conclusions: don't try this at home. Only a few vehicles done, so it could change, all these sort of things, but this is what I believe is happening. EGR flow control is less precise at higher EGR commanded. If the cooler starts to block, EGR commanded increases and the precision of control reduces. With a free-flowing cooler at 2,500 RPM, 36% EGR commanded is sufficient to achieve the necessary recirculation. When the cooler is 66% blocked with that simulated restrictor, that 36% goes up to 64% EGR commanded is required at 2,500 revs, and of course the precision control of flow is lost. So, and in that condition, with the restrictor fitted, soot collected by the DPF did not reduce. My son's Seat has got 67,000 miles on it. That requires 84% EGR opening at 2,500 revs. This suggests that there's significant blockage somewhere in the system, but no faults or warnings illuminated in my son's car. Precision control has been lost of the EGR system. But to my son, the vehicle drives perfectly well. There's no faults. There's no lights. It's great. So yeah. So that's that. But the suggestion is, of course, is that if anything ever wanted to increase the EGR flow, like for instance, we put the car in for a fix and it says, yeah, I need more EGR flow, as we know it does, EGR commanded would go up and most likely would raise a fault or put the vehicle in limp mode or worse. It could cause an EGR repair to be required. So to me, so two things come out of it. One is the blocking of using a restrictor doesn't reduce the soot, and two is with older vehicles which are partly blocked already, it shows conclusively that the extra demand by increasing the EGR flow is almost certainly going to raise a fault or put it into limp mode or worse, and this is one of the problems that people have been having after the VAG fix. Thank you much for listening.